Okay, so jumping to the second page of lesson 5.2, getting, no longer talking about the names of the angles, but now starting to talk about their measurements and how they relate to each other. So back here on the names, if I can actually get to it, I put a little symbol next to it saying whether they were supplementary angles, or in other words, they add up to 180 degrees, or whether they were congruent, meaning they're the same exact measure. When you're dealing with parallel lines, whether it's a parallelogram or just simply two parallel lines and a transversal, you can follow this simple motto of, if they look the same, then they are the same. What that means, if they are both acute angles, meaning less than 90 degrees, then that means they're exactly the same. For example, if you look at this right here, this angle here is 50 degrees. It's an acute angle. Angle A, also acute. They both look like they're about the same size. Based on the rules of parallel lines and a transversal, they are the same size. It's when they are not the same type of angle, meaning this one's acute and that one is obtuse, all right? Or if I look at angle C, for example, this is an acute angle, it's 50 degrees. Angle C right here, that's obtuse. It's larger than 90 degrees. That means that they are not the same. Together, they would add up to 180 degrees. That's how I was able to figure out that angle C is 130, because 50 plus something needs to equal 180. Just subtract the 50 from the 180 and you get 130. So here I can say, oh, angle B, that's acute. Angle D, that's acute. That means they all need to be equal to 50 because they're all the same. In example 3, you stick with that same idea as far as how to set up your problem. If they look the same, they are the same. Set the expressions equal to each other, and then you can solve. Where if they don't look the same, maybe one is acute and the other is obtuse, that's when you want to add the two together and set it equal to 180. So in this example, this one might be tough. Here I can tell that that's a 90-degree angle because they give me that little box measure. And so I could say, all right, well, that looks like it's a right angle, or that is a right angle. That looks like it's a right angle. I could kind of go with that, or I could also go with the idea of, when I have parallel lines and a transversal, these are alternate exterior angles, and alternate exterior angles are always congruent according to this. Alternate exterior angles are congruent. So that means I can set them equal to each other, which I did. 2x plus 30 is equal to 90. I set that up. I solve for x. Keep in mind, when you find that value, that's only the value for x. It is not the actual angle measure. If you want the angle measure, you'd have to plug it back in, all right? Now, in this case, we just needed to find x, so we were good there. Here in example 4, notice, it says find the measure of each angle. No, sorry, find this measure, find this measure. Notice that expression right there, this angle, notice how it opens up real wide, all right? That's greater than 90 degrees, that's obtuse. This one, it's like kind of closing, it's less than 90 degrees, so that's acute. They are not the same, which means they're supplementary. You want to add the two together, which I did here, and set it equal to 180. Then you can solve, get your answer for x. Keep in mind that's not your angle measure. You need to plug that value back in here and here to find those measures. Now, in all honesty, if you plug it back into one and you find one measure, you don't have to plug it into the other. You could just subtract that from 180 degrees to figure out the other one. I just showed you how to plug it in just for, seeing what the steps would look like.